welcome to this week's episode of Automated, our weekly robotics podcast, which we do every single week. We've released an episode a week for the last several weeks. You just couldn't find them because we hid them from you, but all your friends enjoyed it. But this is Automated, our weekly podcast where we talk about robots. We spitball some robots together, and then we talk about different issues in the broader robotics market. And this is going to be a special episode because we have two fan-requested sets of topics. One fan sent in a list of technologies and applications for us to play in our little game. And another fan who totally I didn't meet for the first time on Monday told me about a cool area to apply robots that we're going to spend time talking about. Who's this guy sitting across from me?
So it's been a minute.
Yeah.
We're out of practice with our podcast, I think.
Yeah.
Yeah. A little bit of chaos on the Polymath front. We've been moving. We've been trying to get a bunch of things all sorted and organized.
I've been on the road 3 of the last 2 weeks, and I'm on the road next week again.
Yeah. So sorry for the missed schedule, but
it was personal.
Definitely. For those people who couldn't find the hidden episodes.
Yeah.
It's absolutely personal.
All your best friends listened to them and thought they were great. We just didn't want to share them with you.
That sounds about right.
I, of course, am Stefan Soxmacher, CEO and co-founder here at Polymath Robotics. The gentleman wearing the House Atreides shirt as an insult to his Harkonnen blood is, of course, my co-founder, Ilia Baranoff, our CTO here at Polymath. This is your first time ever joining our podcast. We apologize that we didn't send you our special episodes that we hid from the regular listeners, but this is our regular weekly podcast. The first section, we're going to play a little game and invent some robots. And the second section today, we're going to talk about shipboard robotics. Now, you might hear that and think we're talking about robot boats, but we're actually talking about robots on boats, which presents a whole list of fun, interesting problems that I'm really stoked to talk about. So that being said, let's play a little game.
Would that be robots?
Nope. Be boats on a rowboat, but not the boats actually rowing.
Nah. No
Yeah,
fun.
geez. So here's our little game. We're gonna pick a technology and then pick an application to kind of simulate inventing a robotic startup. And listener Adam A, because I think they always do some anonymizing, actually reached out to us and sent us a list of technologies and application areas. So Ilia, for our technologies, can you pick a number between 1 and 4?
3.5. Or did you mean integer?
An integer between 3 and 4.
3 then.
All right. So 3 is a nuclear battery powered robot.
Nice. I like it. Sweet. We're gonna have fun with this one.
And now Ilia, pick a integer. Or actually, integers are always positive, or
Nope.
what's a whole number? What's greater than 1 but whole numbers?
I mean, but you're also telling me an integer between these two numbers, so you don't have to specify positive.
Okay. All right. Pick an integer between positive 1 and positive 10.
6.
Swamps. Nuclear powered robots in swamps.
Amazing.
If there's 2 things I want to combine, it's nuclear runoff and the water supply.
Yeah. Oh man, I feel like this is how half the Marvel comic superheroes are playing.
You know, if we do a really good job in this episode, I think it will turn into a Marvel supervillain. So I gotta say, when I saw swamps as an application area, I jumped to fan boat.
Yeah.
Like it's got to be a nuclear powered fan boat.
You and Archer, I think.
Yep, definitely.
Danger zone.
So Starsky, our first driver out test was on a more or less shut down public road that we call, or no, not our first driver out, but our first driver out like low speed test at 25 miles an hour was on a mostly shut down public road in Herndon County, Florida, which is just south of like Lake Okeechobee, probably like a mile or an hour or two from the shore. Lake Okeechobee used to be a massive Everglades swamp and has gotten a lot smaller since people wanted to have houses. And the county counselor, commissioner, something of Herndon County was like, you come down here, we'll do some tests. You come back, I'll take you out on a fan boat and we'll go gator hunting. And I am so sad that didn't happen. I don't want to shoot an alligator, but if I had to shoot an animal, I'd want it to be from a fan boat and be an alligator. I gotta say, that's peak.
Send your hate mail to knowledgeai@polymathrobotics.com. PETA, we're looking at you.
So here's what I'm thinking. I'm thinking we need long endurance fan boats for swamp like environments. Now, maybe this is for ecological surveys so that we can notice how mangrove forests decay over time as we put more nuclear waste into the ground, or like microplastics or whatever. Alternatively, the use case could be just for like patrolling in case the Floridians are going to invade us coming from the Everglades.
So,
or alligator people. Isn't one of the Spider-Man villains an alligator man?
You'd know better than I do.
Yeah. So like we got to keep him in the swamp.
So here's the thing, right? NASA has actually deployed nuclear powered robots before.
Yeah.
It's like the Mars lander, the most recent series of
like the suggested technology was nuclear battery powered robot like the Mars rovers.
Yeah, exactly. So there's two, let's call it two. There's really three.
Mm-hmm.
All right, let's do all three. There's three ways to get power from nuclear energy.
Okay.
A nuclear battery, there's kind of been interest in that recently, but that's the least practical one today. Where you basically get a nuclear...
You're saying my nuclear powered fan boat is not practical?
Well, we'll get there. The term nuclear battery in quotation marks, right? You can get a material that emits electrons, and then you can encase it in another material that's non-radioactive. They'll pick up those electrons and use them as a power source. Mm-hmm. So you can get literally nuclear batteries, but they output tiny amounts of power over very long periods. So they're useful for like a tiny IoT sensor that you need to throw somewhere for 50 years and never maintain it.
Like a listening device.
Yeah, like a listening device.
You just described like, does the CIA have a small nuclear battery program?
I'm certain they do.
Yeah.
Certain they do. Right? Because you can...
I wondered how you could like have a long durant... Like there was that set of listening devices in the American Embassy in Moscow that were like in the wall for like 15 years.
Oh, no, that was even more interesting.
Did they microwave power to it?
They would radio power to it.
Yeah.
It was radio power. But it wasn't even radio power. It was radio emission and then looking at the reflections coming back and decoding the reflections because the antenna would get wiggled by sound
People
pressure.
always want spy tech to be cars with guns in them, but really it's like clever ways of powering things at a distance.
Yeah, and encryption. Lots and lots of encryption. But yeah, so nuclear batteries, the listening device stuff, sure. I mean, but in general, it's not going to be a lot of power. So that's not really realistic. The second way how the Mars lander works and how our long distance probes work is thermonuclear. So you just have a lump of metal that glows really, really hot.
Yep.
And then you stick a heat sink on it and you put a Peltier chip in between the two that makes energy.
It's a Peltier chip for the dumb listeners who don't know that.
So
the dumb one, like not me, I know. How would you? I want to hear it in your words.
So there's a Peltier effect where using certain metals and certain materials, you can apply a current and one side would get hot and one side would get cold.
Oh, that's cool.
Or you can make one side hot, one side cold, and you'll get a current out.
Cool.
It's both directions.
Yeah.
Cheap mini fridges is the place where people will most notice it. If you have a cheap mini fridge at home that's the size of a small suitcase, probably uses a Peltier. Unless it's big.
What type of metals have this effect? Or is it like a special treatment you do to like aluminum?
I'm material science and chemistry is my weakest by far. I don't know. There's some material you flow electrons across, one side gets hot, one side gets cold. It's a heat pump. So yeah, if you have a nuclear material on one side and a heat sink on the other side, you'll get power out of it. The Mars rover, what it does is that sort of power is better than nuclear battery, but still pretty low. Mm-hmm. So it still has batteries on board, which get charged up by this nuclear power, and then it releases in bursts when it's driving around, and then sits for a while.
It can't actually move. Like I always just figured it was like a really small nuclear reactor.
No, that's the third type.
Yeah,
the third type is you directly apply water to your nuclear material.
So in other words, like probably a nuclear battery is not really going to power my fan boat to do round the clock gator patrols.
Unless your fan boat is the size of a small US nuclear submarine.
I mean, it
probably not going to happen.
I'm sure like ChatGPT could make one for me.
I'd say the most common small nuclear reactors are those ones.
Yeah.
There's been a revolution in recent years where there's a lot of companies chasing small nuclear power.
Yep.
Like small, almost they kind of describe them as city-sized AA batteries that you can stick into your power grid. But nobody's actually sold one yet. There's been a lot of R&D.
If it's a proper nuclear battery, as is the prompt, where we're more thinking like what's on the upper edge of a small IoT sensor. Like if it's a car battery sized nuclear battery.
I mean, like milliamps, like tiny. Yeah, they're really
So not fun.
Yeah, I mean, side note, you can make a nuclear battery at home if you really want to. You can get those little glow in the dark keychains.
I think we just got a list.
Put on a CIA
like that Boy Scout.
No, cheap way to do it, right? You can get these little nuclear keychains. Even I have one where I think it's tritium gas and wrapped in phosphorus, and so it glows. Mm-hmm. So if you just take a bunch of those and stick it to a solar cell, then your solar cell will output power at tiny, tiny currents. And like, there you go, nuclear battery.
Yeah.
But like, its efficiency is atrocious.
Well, I guess like if we did the second type, like the Mars rover you said is bursty. Mm-hmm. So like, how could you do a nuclear power, like a small nuclear reactor quadcopter?
Well, no, definitely not a quadcopter. I think the energy density is way too low. I think the thing that we're on a swamp, though, actually helps us out.
Because we can float?
No, because who cares about the swamp, right? So what you do is...
the alligator people. No, maybe we messed this up and that makes alligator people.
That's right.
We got to keep Spider-Man at bay.
Because you know what we can do is we can literally immerse the plutonium in the swamp water. It will boil it, and then we just put a turbine over it. And it is the smallest and cheapest nuclear reactor I could think of. It's basically a tube with a fan in it and a chunk of plutonium at the bottom that you just sink into the water and you get steam out of it. That is like the smallest, cheapest
How much
reactor
shielding would you have to do to not irradiate the water?
The water's getting irradiated. I thought you were going to ask how much shielding you have to do to not irradiate the person standing next to the water. And the answer is too much to make it practical.
Yeah, okay.
The water is absolutely getting irradiated. This is a no sense safe.
Okay, so if it had to strictly be a nuclear battery, then like we're probably just thinking of sensors to track the alligator people.
Yes.
So maybe step one, we do a nuclear reactor in the Everglades that is being actively cooled by the Everglades to patrol the Everglades to watch for the emergence of alligator people or crocodile people. Yeah. And then we have nuclear batteries that watch for alligator people.
So here's my question. Does the Everglades want to get significantly warmer? Because I feel like that would cause
people
problems.
Always talk about how Florida is too hot, too cold.
Yeah,
they want to heat it up a little bit.
Yeah, so just stick it in there. You'll be fine.
How big would a nuclear battery have to be before it could power something that consistently moves?
So I think
to run a like an Orin and some motors. A nuclear battery powering a delivery bot. How big would the nuclear battery have to be?
Way too big. Way too big. I think burstiness is still feasible. Because if you think of most robots, right? Even most robots aren't moving constantly. Like even a quadrotor will fly and then land and do something.
Yeah.
So I think burstiness is not that big of a deal. Because if you're monitoring for alligator people, you might want to sit and monitor, which is a relatively low power thing. And you could do that with a small thermonuclear.
Well, if you wanted mobile sensing in the Everglades, so there's like sawgrass that comes out of the water. Yeah, it's like relatively tall. So what if the robot was like a long noodle, like a pool noodle that like slowly rolled over the grass, like really slow, like nearly imperceptibly slow. Okay, just like kind of at a constant tick from a nuclear battery.
And why is it rolling over the grass? What's the goal?
To move from one point to another.
But doing like crushing everything beneath its feet? What is it trying to do?
Like, I mean, it's monitoring weather temperature from the irradiating robot from one spot to then it rolls over, 10 miles of grass to get to another spot.
I still think fan boat is our best option here.
Yeah.
We immerse the chunk of plutonium in water. We get a bunch of steam that we capture under the boat so it's an air cushion. And then you use the excess steam as your propellant.
Or you could just it could be like those like jetpacks, those like in the water jetpacks, where it just shoots out water at the back, but you're shooting out irradiated steam on the alligators to create the alligator people.
It's a self-fulfilling prophecy. I'm sure those water jetpacks use unbelievable amounts of power.
Yeah.
Like moving water at any kind of rate is so energy intensive.
Yes. Water is heavy.
Yeah.
Okay, so actual nuclear batteries are probably off the table.
Yeah.
Commercially, I don't know if I feel like there's a reason fan boats only exist in like 6 movies in the 80s and people who apparently hunt alligators. Because there's a very small set of the world where fan boats are particularly relevant.
So what is this robot doing? Is this robot hunting alligators, or is this robot protecting the alligators from the alligator people?
I think the alligator people are alligators who have been irradiated into becoming people. So we're on patrol duty against alligator people invading the retirement communities of Central Florida. I think what's hard is I don't have many business use cases of what happens in the swamps.
Yeah, I mean,
I feel like similar to quicksand, swamps were a way bigger part of my cartoon upbringing than they've been a part of my real life, and I've spent decent time in Florida.
But I feel like you didn't grow up in Florida.
Yeah, but most people who grew up in Florida don't live by the Everglades because it's been turned into a series of strip malls.
It's more like a bayou thing.
You could basically use it to do different tending tasks for like a fish farm in the Everglades.
Do people farm fish in the Everglades? Is that
I assume you could. Why couldn't you?
Well,
it's fresh water. It's not that deep. You could put like pens up and, basically patrol to scare the alligators away.
Excuse my optimism, but I was assuming the Everglades are kind of protected.
I don't think a lot of them are. I think as a portion. I think yeah. I mean, Florida went from being like a relatively backwater state 80 years ago to being the second most populated state in the country, largely because there was like unused wasteland called the Everglades that they just like kept on building developments into. Because you just would drain a chunk of swamp and boom, build a Winn-Dixie and some, very uncharming homes. And now you have another over 55 community.
Well, I think we haven't gotten to a robot, but we should wrap this up because this has been a long one. What are we naming this terrifying thing?
Gator 3000.
It's a friend to the alligators. It's the alligator.
I was asked to think about a really interesting area for robots recently. So a gentleman came up to me at an event and said, had we thought about shipboard robotics? And I talked about some boat stuff that we know. I was like, no, I'm not talking about robot boats. I'm talking about robots on boats. So whether that's like a naval vessel or a cruise ship or a freighter, like what are different places on boats where robots can add value? And so some interesting challenges here as we dig into it a little bit. First of all, you live in a Faraday cage.
Yep.
The boat is metal.
All the metal everywhere.
Metal everywhere, right?
Yep.
Second of all, the ground moves.
Yep.
It sways, it tilts.
Flexes.
It flexes all the time. Third of all, especially if you're on a military boat, you can't talk to anywhere else in the world.
Mm-hmm.
No sensor data can leave. You're stuck on board the vehicle. Boom. Enter robots.
Well,
so how do we build robots that can and like I think a separate challenge is what are valuable things robots can do on the boat?
Yeah.
Which I struggle to immediately think of. But let's just think about how do we get something navigating in a boat?
So, okay, related, right?
Mm-hmm.
Something I had thought of to do for a fourth year design project in undergrad, but ended up doing a different thing, was actually automated rescue robot.
Okay.
And then last year at CES, I found there is actually a company that builds this now, which is great. So the idea being for high risk jobs like crab fishermen, where people get washed overboard relatively recently or relatively commonly.
That's mostly because other people push them.
Sure. I'm not, I think it's more. Anyway. Basically, you have everybody on board wear a bracelet. And then if they fall overboard, there's an automated system that'll launch a little life-saving torpedo robot that just swims out to them and inflates into
That's pretty close to being a robot boat.
But it's.
I'm thinking the challenge is robot in Faraday cage.
In Faraday cage.
With tilting ground.
Oh.
So like one thing that I think I've thought of. So, and I don't know if we've made fun of these in Star Wars before, but take any piece of Star Wars media and there's these stupid little rinky-dink robots trudging along that seem to just be boxes. Walking infinitely from one place to another and getting people's way. Yeah. Walking trash bins. So a thing I thought is you could do something like that is functionally a generator that moves from point to point in case like you need to do work somewhere and you need more power than is available to you.
I feel like,
or a battery.
But boats are so heavily designed, especially military ones.
Yeah.
They're so carefully designed to avoid that sort of thing.
Where you need to do work somewhere where you're not. But I mean, I
mean that you wouldn't have power available everywhere you could possibly need it. Unless there's a real.
Well, let's say you have to do some welding somewhere.
Yeah.
Like bring the equipment for a welder, bring sufficient extra power to do some spot welds to fix up the bulkheads with the screws and the plates.
I think I might go a different direction. So the thing that always surprises me about aircraft carriers, knowing zero about how aircraft carriers operate, is there's so many people on the deck. There's so many people, and that just seems very dangerous to me.
As a reference and potential spoiler, Ilia and I were arguing at lunch over the Expanse series and the capability for a navy to bring enough people to a world to then build themselves a new navy 30 years later.
Well, not even that. It's just that I understand you want somebody to be directing air traffic and that sort of thing, but why is loading of munitions done by hand currently? Like, that seems pretty inefficient.
It's a complex gesture. I mean, I think my hunch is it's not just loading munitions done by hand. It's also moving munitions.
Yeah.
And it's also someone signing out the Tomahawk missiles from the Tomahawk missile crate.
Yeah.
And then people repositioning crates when the first Tomahawk missile crate's now empty. And we have to get a new Tomahawk missile crate to the Tomahawk missile bin.
Sure.
So like literally like vehicles that just move like boxes of stuff are probably not trivially are probably more valuable than would be logical.
Yeah, exactly. Like just moving bulk equipment in a safe way, in a way that's not going to roll off the deck when it's ship pitches. On the missile side of things, you're dredging up a memory. I read an article that a lot of missile destroyers and those sort of boats have these vertical launch tubes for things like cruise missiles. And the idea was that they're supposed to be rapid swap, where you launch them, you come back to port, or even at sea, you lift out this giant rectangle cuboid, and you slot in a new one, and you're good to go. But the reality has been that each of these swaps take, like, I forget what the exact number is, but let's call it 18 hours.
Really?
Way longer than they should. And they just have not optimized the delivery and installation mechanism for these things. There's just kinematic reasons why it's difficult to maneuver this 30-foot long
So almost like a mobile robot crane.
Yeah.
That was like, that made it easier
to replenish at sea.
Yeah.
In particular.
Yep. I mean, another thought that I have is moving tools quickly from one part of the ship to another, especially like heavy tools that you don't need as many duplicates of. So like a thought that I had is, what if you have your doors, which are, round and off the ground based on movies I've seen. Maybe
in historic ships you can walk through.
Yeah, and historic ships I've walked through. Maybe you have secondary doors, like almost like dog doors, that are flat to the ground and have similar mechanisms to whatever.
No, because there's a reason those are built that way, right? They're built that way for waterproofing.
I know, but like maybe you have the second set of doors that like are waterproofed through like way more pressure immediately crushing things. So like, yes, you wouldn't want a sliding matte metal sheet in your doors that people have to run through. But if this massive metal sheet cuts our robot in half, like boohoo, we'll be able to move tools a little less quickly.
I think it's honestly a mechanical complexity thing. I think there's a reason those doors are mostly manual and mechanical, is they want them operable even if the ship has completely lost power and is half flooded. You still want them operational. And I think with those any kind of mechanism you introduce there is going to get killed pretty quick.
My thought process is
anyway.
These are, they things go down and they all shut, and like this is no longer an available system.
I think you're hitting on a point here, that wheeled robots fundamentally can operate in these vessels because of those doors.
Yes.
And I think we have to have those doors, which means you have to go to legs, which means this is one of the only times I've seen a flat grounded application where legs actually are necessary. Is just to get through those doors.
You still jump them or something.
You still what?
You can still jump them or something.
I don't know. I mean,
hear me out.
Yeah.
You have separate dog doors. So it could be a small robot, like a, I don't know, 6-7 inch tall robot that's maybe 7 inches wide, and then like 24-30 inches long. Just like little like trains that move quickly. Yeah. And the whole point of them they zip through the corners of hallways, delivering like monkey wrenches and like rare parts, so that you need fewer heavy tools at sea, take up less space, and you can like more have efficiency. People move them more easily. I think just looking at how slowly development goes in these kind of things, retrofitting the fleet for this would be a non-starter. I think you just have to punch holes in walls. I feel like punching holes in walls is going to be a big deal for the Navy. Like they're not going to look kindly on that. Just a little hole on the side of the hull. What's the big deal? I think realistically, honestly, like a two-wheeled legged robot, right? So it has legs, but it has wheels at the bottom of the legs.
is probably actually the optimal solution here, realistically, because this is one of those very rare circumstances where you do have really tight quarters that you cannot engineer your way out of. Like a boat is always going to be tight.
Yeah.
Because you're trying to minimize the surface area of the vessel. There's a lot of reasons why you want to make things tight. You have a tight space with lots of impediments at
two
ankle
legs,
height.
2 legs, each of which have a wheel.
Have a wheel. Yeah. And there's a few robot platforms that exist that do this today. That's probably actually the perfect platform.
But then your carrying capacity becomes nearly nothing.
Well, maybe. So what you could do is you could have these robots that they'll tilt up when they need to stand, and then they'll tilt down when they're just driving.
But if they need a stand going through each doorway,
yeah, so they'll
stop, my hunch is like when I was saying moving a monkey wrench.
You mean like right now, 30 seconds across the ship?
Not 30 seconds across the whole ship, but like faster than a human could get there. And the monkey wrench itself is 3 feet long, weighs 25 or 40 pounds or something.
Yeah.
And like, I'm kind of making up a perfect scenario.
Yeah.
If it's something really small, you could have a whole bunch more of them on a boat.
Yeah.
And if it's something really big, like you start to, you can't drive through the hallways, or you might block a whole hallway if you get into trouble. And that's probably a non-starter as well.
I mean, again, like not having any military experience, right? I have no idea. But I would assume that on these boats, there's still a lot of small things that need to go from place to place.
Yeah, but like that's
probably worth it.
You're competing here against literal people who will run the thing.
Yeah.
So it needs to be something that is small that you want to get from A to B, but not so important that like, the captain saying, run this note down to engineering, or the engineering saying, run this spec thing over to the gunner people.
Yeah, I think the longer term goal. Why do you want robots, right? One, it could be increased efficiency, but the other one could be reduce crew.
Yeah, but like, I mean, the captain's always going to have someone run a note for him.
Yeah.
But that's always going to be a thing.
Yeah.
Like the top secret orders of when we strike the alien forces are always going to be run by a person by hand. Alligator people, aliens.
Stefan was born and bred in the U.S., so when he says alien, I'm not exactly sure what he means, and I'm going to make no claims on knowledge.
But like I think the challenge here is like above a certain level, it's going to be moved by people.
Yeah.
Below a certain level, if you want to reduce people and if you want to reduce stuff that sits on the boat, it has to be big and bulky. Which then puts hard pressure on your robot. Just
bringing a coffee to the guy on watch from the galley, like I'm sure that's a common concern.
I think it's probably easier to pre-position espresso machines than build out a robot. I don't think bringing a coffee is a use case here. Like
we should, you know what?
That's why God invented Nespresso.
We should reach out to your contact and actually ask. Did he give any hints as to what he was interested in?
He wants to form a group to explore.
To explore.
Yeah.
Okay. Because I mean,
but I think the operative thing is like what is doable and what is hard.
Yeah.
Like so, like actually, like this conversation is a useful thing.
Discussion of what is doable.
Well, like so, like let's say there is a use case.
Okay.
Like let's
inspection. Let's call it that, right? The ship is mostly steel, so you can use magnetized legs / wheels / whatever, and start to inspect every nook and cranny of the ship at sea, if that's important.
And there's probably some regular dumb maintenance.
Yeah.
That let's say you have a magic arm.
Yeah.
You could do some number of tasks.
Just painting, repainting paint that's flaked off.
Yep. Only in the areas that are accessible, so you'll have a multicolored ship. So let's talk about like actual navigation in a ship.
Okay.
So you have these doors. Yeah. So like let's say the Navy lets us just drill some holes, or Carnival Cruises.
I'm still gonna feel like that's just not a starter on the Navy ship. Just punching holes in random places. It's like sorry. Quick tangent. I saw this really interesting thing that was like we can transfer large amounts of power ultrasonically through material. That was this company that was doing
microwaves.
No, not microwaves. Like
rays.
Through metal, they could transfer like 100 watts of power.
Microwaves.
Not through metal. And I kind of was chatting with them, and I was like, wait, what's the use case here? Like, this is cool, but like, what do you need this for? And like, oh, we're thinking like for submarines and stuff. And I'm like, the submarine controls emissions extremely tightly. Putting 100 watts of ultrasound on the hull of the ship would be not a good idea. Similar to this, like I feel like the Navy controls holes in their walls extremely tightly.
Well, I mean, that could be for Carnival cruises. Like they can have less people. They also
don't have dog doors at that point.
They could add them.
Yeah, just for
and dog doors. No. All right. So the door problem has been solved.
All right.
How do we localize in a series of gray cuboids, of which, like, my hunch would be, if a Carnival cruise can fit like what 15,000 people in it,
sure,
there's probably a bare minimum of 45,000 rooms. By which I mean, like, a room can be a hallway, a room could be a bedroom, a room could be a galley, a room could
storage
be
closet, whatever.
Yeah.
Okay.
Yeah. So 45,000 rooms, no more than like 20% are unique.
Yeah. I mean, I think what you do at that point is the robot has to have some idea of what floor it's on, at least, which I think there's ways to cue that.
How?
Everything,
I mean, including if you do a hard restart on floor, how do you know where
everything
you are?
From having identify yourself by what Wi-Fi station you're connected to. That's probably for a Carnival cruise. You'd have a lot of Wi-Fi everywhere.
Yeah.
So so that, like, you could do a pretty reasonable lookup of, like, I'm talking to AP number 367, and AP number 367 is on floor 6. Like, I know this.
Well, but isn't there a chance that AP, the 6th floor leaks onto the 7th floor in some spots?
Absolutely. So you wouldn't just do this with one station. You triangulate, you'd roll around a little bit, you'd figure it out. So localization, it's like, you know, if I'm sure this is an experience that is totally alien to you, Stefan. But if you were to wake up completely with no knowledge of where you are, slightly delirious and headachy for some reason on the floor in some unfamiliar place, you would also have no idea where you are until you wandered a bit and got your bearings. So I think that's allowable.
This is co-founder abuse.
I'm sure you've had no experience with it. So I think that's okay for a robot to wander a little bit until it gets its bearings. The other things, though, is you can sort of do a little bit of image character recognition for things like room numbers, because those are not going to move very much, or other unique features.
I mean, you could, like, put if a Carnival cruise swapped out every room number or room sign with something that had an April tag hidden behind it.
Yeah,
you could use that as, like, a really good localization.
Yeah, but again, like, I think the key, you know, from a business and technology standpoint, adoption of robotics is hard enough already. Forcing your customer to input a lot of infrastructure to support a robot is really hard. So the more we can get away with too little,
of course. But better. Like, if there's 45,000 rooms, there might be in the range of 100,000 of these, like, room tags. So, which, like, would be relative, like,
but I don't think it's necessary. Honestly, I don't think it's necessary. I think Stefan bot wakes up from its coma,
doesn't know where it is,
wanders a little bit until it gets a rough idea, and then downloads the map of that region because it's too big to store the whole ship in memory. Maybe we can, but I think at that point you're paying a lot for storage on each individual robot, where you should just have a server central.
So if you have connectivity throughout, it becomes easier.
Way easier.
But if it was a military vessel, military vessels probably don't want Wi-Fi everywhere.
Yeah.
For the bare minimum of that, it's a trackable thing by others.
Yeah, I mean, there's a lot of reasons.
I wonder if anyone's doing, like, long range, like, oh, there's a thing over there because I hear some leaky Wi-Fi.
Well, okay. Time for tinfoil hat conspiracy time.
Yeah.
Really fun feature of most of your digital devices that you might not realize is when you connect to a new Wi-Fi, it will broadcast out all previous Wi-Fi connections it's had. So you can actually...
the Wi-Fi will tell me everyone else you talk to.
So your iPhone, you walk around...
The office.
Yep. And our office name is Polymath.
Weird.
Right. Then you go visit U.S. Navy, and you connect to their guest Wi-Fi. Their AP will know that your device has previously connected to a Wi-Fi address called Polymath.
Why is that needed?
That is a feature baked into the standard so that it knows what APs you have access to and will reroute you to those. So the advice from corporate IT security is never to actually name your Wi-Fi addresses as anything company related.
Yep.
Because if you're a vendor and you go to somebody else's site and it says, oh, I visited, like, Intel and now I'm at AMD's office, like, surprise. So yeah, listeners, don't name your
feature that's sold?
That's no. That is baked into the standard.
No. What I mean is, so like, screw tinfoil hat conspiracies.
Yeah.
Let's say you're a VC and you want to get a sense of whether or not well, does it tell you how recently? Would it tell you how recently?
Yeah. I mean, I don't remember off the top of my head all the details, but it tells you a lot of, like, surprisingly more than you'd think.
So let's say that you're a VC and you have a company visiting you and you don't know whether it's a hot deal that like is getting a lot of attention or not.
Yes.
Like,
look at their previous Wi-Fi connections. Absolutely.
Wow.
Absolutely. This is why my home Wi-Fi does not relate to my address at all.
Mine doesn't because I moved a couple of times and I'm lazy.
Yeah. No, it's a real, and like, you don't need special equipment. Like, if you just get slightly above consumer grade Wi-Fi stuff,
like even any Meraki AP could do this.
I mean, even OpenWRT will give you previous AP addresses.
Jeez, that is, yeah. Well, so sorry, but like, but like my broader thing was, if like, I there's a square power law or whatever with Wi-Fi emissions.
Yeah.
But if there was, Carnival Cruise Princess of the Sea, and I had a sniffer floating in the ocean, from a mile away or from some distance away, I might hear a signal, Princess of the Sea Wi-Fi. And then I could know, like, there's probably a cruise ship nearby.
For reception, it's always a matter of how big is your antenna.
Yeah.
And now with phased arrays and more intelligent, very accurate timing and processing, you don't even need one single giant antenna. You can just have a few small antennas spread out geographically. And then you can monitor whatever the heck you want.
So Carnival probably is okay doing that.
Yeah.
But probably no naval vessel has Wi-Fi.
Or if it does, it's very tightly controlled.
Yeah.
Time-wise and power emission-wise.
And turned off anytime they don't want people to know where they are.
Have any actual mission,
Yeah. So if you're in a vehicle like that, you're not going to have Wi-Fi.
Yeah.
You can't assume Wi-Fi.
So for military cases, I'd assume you have enough processing power and storage to store a map of the entire boat.
But if it's a Carnival Princess of the Sea size boat, like, you're not, that's going to be the same problem.
No, that's a centralized server with Wi-Fi connection.
Yeah. So if it's a big boat and you need to go anywhere on it, you need Wi-Fi.
Yeah.
I mean, or could you have a dumber, smaller localization system? Like, let's say you could swap out the signs on every door.
Yeah.
And you could localize where you are relative to 3 signs, like just in terms of like how distance from signs. You could and then you could like with relatively simple logic tree, I could know like these signs are placed in a certain way. The sign that says this is towards kitchen, if I need to go towards kitchen, I follow that sign. So, and basically build a quasi unique global planner for localizing in ships.
So the problem with that is always, what are you trying to do? If you're just trying to navigate in a direction without hitting anything, that's probably fine.
Yep.
But if you're on a boat, your probably job is to deliver towels or whatever.
Yeah.
Is to get to a very specific geographic point, which means you need to know where that
there's logic to how the points work. Like, so if it's Carnival Cruise Room 1522, and the schema is that means deck or 1522R or 1522P, and 15 is the deck number. P means it's on the port side of the boat. The numbering scheme is 0 is the closest to the engine and 99 is the closest to the front. Then like you could have a not trivial but smaller memory bandwidth than an HD map navigation system for realizing that, like, okay, I'm in the towel room. I need to go to room 1522P. That means first I'm on towel room on deck 1. First I need to get up to deck 15. Then I need to navigate to the port side, and then I need to get to door 22.
So there's the question, right? So start at the start. How do you know how to get to the elevator if you don't have a global map, right? If you don't have a global map, you don't know which way to go. You can wander randomly, but that's going to take you a long time.
I think my thought is you have a multi-tiered global map that is not high definition with a lot of like Boolean logic.
Yeah.
And like, so I know where I am right now because I can currently see these 3 signs.
Yeah.
And these 3 signs are towel room maintenance, towel room dispenser, and this way towards elevator.
That's if you see that sign.
I mean, it might mean you need to put a lot of this way towards elevator signs.
Yeah. I mean, same for humans, right? Same for. I mean,
there's a standard for how frequently you can say exit. You can also probably localize off of exit signs.
Because exit will.
If you had
doesn't have a single exit, right?
Yeah, but if you had an April tag on each exit,
there's
an exit time. There's a standard for distance between exit signs.
Yeah.
So like you should never be more than 100 meters from an exit sign, probably in your life. Your life inside built environments, you're probably never more than 100 meters from an exit sign.
Yeah. Okay. So Talbot can wake up and have a rough idea where it is.
Yep.
And then localize and navigate entirely in kind of local obstacle space with no real memory of what it's seen.
Yeah.
It's feasible.
Boom.
Sure.
New PhD paper.
Yeah. Localized based on cues.
Mm-hmm.
Yeah. I still think probably, I wonder if any of because there are like Savvy Oak, for example.
Yeah.
There's a few providers of Tal delivery robots, to call them in short form. I wonder if any of them have deployed to boat. And if they have, what was the problem or not?
It's robots, so there was a problem.
Of course.
So which one was the problem?
Yeah. I mean, I'm certain the uneven flooring.
I also wonder if, like, given that the boat moves in swells, I wonder if you can make some logical conclusions based on how it moves to figure out your heading.
Your left and right. Yeah, that makes sense. Because your boat's not going to rock forward and backward nearly as much as it rocks left to right.
Unless things are really going bad, I think.
At that point, you're in such a bad storm.
You should be locking down.
Yeah, exactly. You're in such a bad storm that probably TEL service is not the main problem.
It's a priority. Just not at the top anymore.
So you know what you have to retrofit? This is the main infrastructure. Every 100 meters, you have to put up those little seatbelt signs for airplanes. Except it's a no TEL service sign because it's too thick. Like, I'm sorry, the seas are too rough. The robots are not deploying today.
You know what else? Actually, you know what else you could localize on? Fire extinguishers. Not fire extinguishers. Fire suppression system.
I mean, generally you can localize in the ceiling.
Yeah,
the ceiling doesn't change very much.
No. Sorry, I don't mean like with memory, but I mean like you're never going like if you're never more than 100 meters away from a exit sign.
Yeah.
You're never more in life. You're never more than 10 meters away from either a smoke detector, a fire alarm, or a sprinkler.
Yep.
So if you have something unique looking on your sprinklers, you can localize off of it.
So I think to your point, if you don't have a global map, what you could do is have, like you said, some heuristic numbering scheme.
Yep.
Which
already exists.
Right. And so you detect the first fire hydrant and it's ID number 1522R.
Yep.
And then you keep rolling and the next one's 1521R. And you're like, okay, so now I know which way I'm heading.
Yep.
And roughly what quadrant of the boat I'm on.
Yep.
And then you have a programmed heuristic to say that the elevators are in these zones. Yep. So head towards this zone. And then you only have
to solve the problem with elevators and robots, which is also an easy one.
Well,
no one's ever had trouble with that. There's definitely never been papers or whole massive initiatives to solve elevators.
I think the big one there is that if you do have Wi-Fi connectivity, it is you tap into the elevator's control system, right? Yeah. So the robot doesn't press a button. That's kind of the dumb way to do this.
I think the robot sticks a little like finger out with like a gear. Yeah. And then there's like a universal
R2-D2
gear receiver at the elevator and just twists it while doing like.
That's Stefan's goal is just always recreating Star Wars.
I mean, I've been desperately trying to figure out a reason for astromechs to exist. And the best thing that I can think of is like maybe there's a use case like it. No matter how good Moore's law gets, there's a certain size that supercomputers can't get smaller of, and it's slightly too big to want to carry around all the time. So the whole point of an astromech is a mobile supercomputer that can generally interact with things for you.
Yeah. All right. Well, we should wrap this up. Yeah. This has been a good coming back, long rambling episode.
Yep. Nice coming back, and you know we only invented like 3 or 4 new types of localization. So go ahead.
We'll be fine.
Write a paper.
Yeah. Credit Stefan with it.
Ilia, what are we going to talk about next week?
Well, I think, are you traveling next week?
Only on Monday.
Oh, look at you. Look at
I know. We get to spend some time with my baby and sleep
get
on my
to see your
bed.
family. Wow.
Yeah.
Man, Polymath is going soft. All right. So hopefully we'll be back next week.
What are we going to talk about then?
I think we'll talk about how there's inefficient use of sound tiling in this podcast.
As we just set up a new podcast booth in our new office, partially sound tiled it. So next week will sound even smoother. So you better join us. Unless, of course, it's another secret episode we send to all your friends, but not to you.
All righty.
And with that, thanks so much for joining us. We'll talk to you all soon.
See you next time.